Greetings to all our viewers, and you are welcome to this channel, African Science and Humanities Review. In today's episode, we are going to consider some of the basic laws of physical science, and then we are going to look at how important these laws are to us. And the basic laws we want to consider today, they are the laws, Newton's three laws of motion. They are called the first law of motion, Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. And we are going to also relate that to gravity, the acceleration due to gravity, which is the acceleration that is naturally available on Earth. And I believe you are going to enjoy today's episode because the person who introduced this Newton's law, the three laws we are considering today, Sir Isaac Newton, is one of the famous scientists that have ever lived on the planet Earth. And he did a lot of work relating to mechanics, to mathematics, to physics, to astronomy, and so on and so forth. And many of the laws that are available, they are credited to him. And some of the laws look so simple, but at the time in which he discovered these laws, they were not as simple as that. And some of the laws had to be subjected to the procedure of physical science, experiments, and then complemented with mathematical equations. Please, you are going to enjoy today's episode. You are welcome. Thank you very much. Newton's laws of motion. Well, these laws of motion are due to Sir Isaac Newton, born 1643, died 1727. He was a famous English scientist, physicist, mathematician, even you can call him a theologian. He was so many things combined in one. And eventually became a fellow of the Royal Society, UK, and the president of that society. There is no way one can talk about physics, physical sciences, that you will not mention Sir Isaac Newton, because he's a pioneer, he's a modern pioneer in the field of physical science, the field of physics. It's in the same category with people like Albert Einstein. So he propounded three laws, and they are classical laws, and they are known as the Newton's laws of motion. They are three in number, and they have been dubbed as first law of motion, second law of motion, third law of motion. Of course, as the name implies, the laws deal with movement, motion, where you have an object that is in motion. Of course, before the object goes into motion, it will be at rest. And of course, when we talk about objects in general, except we have some, we decided to qualify and put some restrictions, we are referring to solids, to liquids, and to gases. And of course, liquids and gases are referred to as fluid. So the Newton's law of motion governs the physical behavior of objects when they are at rest or when they are in motion. So we will look at the first law, then we move to the second law, we move to the third law. So we want to consider Newton's first law of motion. We have a sketch of a simple, it looks like an object that looks like a vehicle. You can say these are the tires, this is the steering, just for us to have a pictorial view of how Newton's first law of motion operates. So we can see that we are using this arrow to indicate force. So what the law says is that this object, which in this case is a vehicle, will remain at this particular spot like this, except you have a force, something that will move it from this particular spot to another force. It looks like a commonsensical observation, but when it was formulated, it wasn't as commonsensical, because some of the laws of science, except they are investigated scientifically through the methods, experiments, and so on. In one of the episodes, we talked about the procedure of carrying out investigation with respect to all the various branches or fields of science that we consider. So this object is at rest. The Lord just says that this object will keep on staying at rest until there is a force to push it. This is the force that will push it. And also, if the object is actually moving, like a car is moving, the first law just says that it will continue to move, like that. So the force will keep on making it to move along that line until there is another counter force that will make it to stop if it is already moving, or to move if it is at rest. So that is the first law of motion. The object will keep on moving until there is a force to make it to stop or to change its direction, or if it is at rest, it will keep on staying at rest until there is a force that can be applied to change its direction, to make it to move. Of course, if we put a plate on a table, it will continue to remain on that table. You put a spoon on a table, it will continue to remain on that table until you have certain forces that will push it. It's possible you can have a breeze. You put a stick on the ground, on the floor, and you have the stick moving without you seeing clearly any force moving it. But actually, the wind is moving it. So the wind is a force that is moving the stick that you put on the ground. So the second law, Newton's second law of motion. So we have used the vehicle also for us to have a graphical illustration of how Newton's second law of motion, how it operates, what it says. F, as we have used it, is representing the force. That particular concept, a phenomenon that will change the state of a particular object. So, the Newton's second law just says that the force, that's going to apply, that is being applied to change the state of that object, is actually directly proportional to the rate of change of momentum produced. Well, this symbol is used for direct proportionality, in the sense that I didn't have 1 over rate of change of momentum produced. If I have 1, that is inverse, but this is direct proportionality. Shortly, you'll be able to see what we mean by momentum and how we can derive a simple equation for momentum and things connected with it. But we can just see the second law just saying the force is directly proportional to the rate of change. When you talk about the rate of change, you are talking about the change with respect to time. Okay? So it's talking about it's proportional to the change in momentum with respect to time. So now leads us to the analysis of the second law, just like I said. And the first question is, what is momentum? Okay? Of course, when you say it's a change of momentum, that there is a momentum, there must be a final momentum and then an initial momentum. Newton's second law analysis. So you can see that the F, which is the force, is equal to the momentum change all over time, based on what we have here with respect to the direct proportionality. Okay? The momentum is actually the mass of an object times the velocity, because momentum measures the impact. If the vehicle is speeding, is going on the road, you have the regarding mass and the speed, the velocity at which it's going. Then you can talk about the impact if anything should happen to the vehicle. So the momentum change is the mass times the velocity, which is actually the momentum. Okay? If we're introducing the final momentum and the initial momentum, it could have been the final mass times final velocity minus initial mass times initial velocity. But we are just talking about momentum simply here. So it is mass times velocity all over the time. Okay? Which is equivalent to what we have there. We said it's the rate of change of momentum. So change in momentum all over time. And then we can simplify this further by saying that that is the beauty in mathematics. Once we still maintain the variables, we can just say mass times velocity all over time. We can simplify it that way. And we know velocity over time is the acceleration. So indirectly, we are saying that the force that can be exerted on an object can be described in terms of the mass times the acceleration. So if you represent the mass by small letter a and the acceleration by small letter a, F is ma. And the unit of force, you can see the unit is Newton. It is in recognition of the great works that Sir Isaac Newton did with respect to motion. And this area of physics is called the mechanics. When you talk about mechanics, you can talk about static and you can talk about dynamics. Static, we are talking about the motion, the state of an object when it is at rest. And then the dynamics, the state when it is moving, so to say. So the unit of force is Newton in honor of Sir Isaac Newton. So we have considered the first law of motion. We have considered the second law of motion. We now want to consider the third law of motion. So what the third law of motion just says is that if the object that is moving is either is moving and there is a force that is applied to it, the action is a force, the reaction is a force. So the third law just says that action and reaction, they are one, equal, and two, they are opposite. So you apply action here. If you want to change the direction or the state of that object, you apply another force in the opposite direction, reaction. And we can use a simple mathematical equation to illustrate that by saying action A is equals to minus R, because we are using the minus because it is opposite. You know, we say action and reaction, they are equal and they are opposite. Because they are opposite, we are using minus. So if you add A, if you bring your R to the left hand side, we are having A plus R is equals to 0, which shows the equilibrium state, a system that is at rest. And that has also shown the concept of duality, which in one of the earlier episodes we considered the duality in nature. We gave some examples. This is also an example of duality. When we are considering duality, we said when you have x is dual to minus x. When you are talking of addition, because x minus x plus minus x will be 0. And then when we are talking about multiplication, we are saying that x times 1 will always remain x. So that's also brought to the fore the concept of duality. So having considered the first law, the second law, the third law, we now want to naturally link it up with the law of gravity, which is a very important law, which also deals with motion. It is very significant because we have all done it, we have all witnessed it one way or the other. When you pick a stone or you hold an object up and you throw it, you just hold it and release your hand, it comes directly to the ground. That is the law of gravity. And the object will remain on the ground until maybe you have a force to bring it up. So the acceleration that brought it down Remember we said acceleration is velocity all over time. So that acceleration, the natural acceleration that is available in nature, because acceleration can be in different ways. You can calculate acceleration depending on the values that you have for your velocity and the value for your time. But the acceleration due to gravity, which is a natural acceleration, the acceleration which is the acceleration that is available in nature, is called the acceleration due to gravity. That's why we have the object. When you just hold it and you release it, it comes to the ground. So that G, it has a value. It can be approximated to be 9.8 meter per square, because the unit of acceleration is meter per second square. Because when we look at acceleration, which is velocity all over time, velocity is distance all over time. So when you substitute distance over time here, you are going to have a distance all over time times time. Okay, you have distance of, because when you say velocity is distance over time, so if you put distance over time here, you are going to have distance all over time times time. And the unit of distance is meter, and time, the unit is second, but you are having two times. That's why you are going to have second square. And we can really carry a simple analysis by looking at it, given the acceleration due to gravity, which we know is velocity all over time. So you can actually calculate the velocity that makes the body to fall down. And that is, you can calculate it when you consider the time it takes for the object to get to the ground, which is time. So the velocity will be equal to the acceleration due to gravity times time. Okay, when you cross multiply, velocity will be this times this. Also, on the other hand, if you make t the subject of the formula, you can say that the time, when you say g times t is equal to v, so the time is going to be v all over g. So you can calculate the time that is going to take the object to fall to the ground by using the simple formula v all over 9.8. We believe you have enjoyed today's episode, where we considered some of the interesting laws of nature with respect to mechanics, that is the physics of motion. In the next episode and the subsequent episode, we are going to be considering other laws of physical sciences. We are going to exhaust all the laws of physical sciences, then subsequently we move to the laws of theology, and then the laws of philosophy. Thank you for joining us, and please stay tuned for the next episode in the next couple of days.